Hello everyone, this is Tutor Marife MCP. In this video, I'm going to teach you some theorems on circle using this problem. I have here this given figure and I am going to solve for the value of x. And to be able to solve for the value of x, I will be using some theorems on circle. But before I start solving for x, I want you to be familiar with some of the terms that I'll be using in my discussion. I have here three terms: intercepted arc, inscribed angle, and cyclic quadrilateral. Let's start with the inscribed angle. What is an inscribed angle? It is an angle whose vertex is on the circumference of the circle. Let's consider this figure. This is the circumference of circle O. Look at angle A. The vertex of angle A is on the circumference of circle O. Therefore, angle A is an example of an inscribed angle. Look at angle B. Its vertex is also on the circumference of circle O. So this is another example of an inscribed angle. One last example, angle C. Its vertex is also on the circumference of circle O. Therefore, this is an inscribed angle. Okay? Next term, intercepted arc. What is an intercepted arc? It is the section of the circumference of the circle enclosed by the sides of an inscribed angle. Okay, let's look at angle A once more. This is angle A. These are the sides of angle A. We have chord AB and chord AC. This section of the circumference is enclosed by the two sides of angle A, and we call this section intercepted arc of angle A. So the intercepted arc of angle A is arc BC or arc CB. Look at angle B. These are the sides of angle B. We have chord BA and chord BD. The two chords enclose this section. Therefore, this is the intercepted arc of angle B. And we call this arc AD or arc DA. One last example. Look at angle C. These are the sides of angle C, chord CE and chord CA. The section of the circumference enclosed by the two chords is this arc, arc AE or arc EA. We call this the intercepted arc of angle C. Okay? Last term, cyclic quadrilateral. A cyclic quadrilateral is a special quadrilateral whose four vertices are on the circumference of the circle. These are the vertices of quadrilateral DEFG. They all lie on the circumference of circle O. Therefore, the special name for this quadrilateral is cyclic quadrilateral. Okay, let's proceed to the problem. This is the given figure. We will be solving for x. Okay. Let's focus on one theorem. And this theorem relates the measure of an inscribed angle and the measure of its intercepted arc. This theorem tells that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. I'll repeat. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. Angle M. This is an inscribed angle. its vertex is on the circumference of the circle. What is the intercepted arc of angle M? These are the sides of angle M. The section enclosed by its sides is arc LKQ. Therefore, this is the intercepted arc of angle M. And what's the relationship between the measure of angle M and the measure of arc LKQ? Using the theorem, measure of angle M is equal to 1/2 the measure of arc LKQ. Application of the theorem. The measure of an inscribed angle equals 1/2 the measure of its intercepted arc. Okay? We don't know the exact measure of arc LKQ. But we can see that arc LKQ is composed of two smaller arcs. We have arc LK and arc KQ. So we can say that the sum of these two smaller arcs is equal to arc LKQ. So we can replace this with the sum of the two smaller arcs. Measure of arc LKQ is equal to measure of arc LK plus measure of arc KQ. And this is equal to 1/2 the measure of arc LK plus measure of arc KQ is equal to the measure of angle M. We don't know measure of arc LK, but it is represented by this expression, 9x minus 6. So we can replace this with 9x minus 6. The measure of angle KQ is known, it's equal to 140 degrees. So we can replace this with 140 degrees. Let's do it. Measure of angle M is equal to 1/2. Replace this with its representation. It's 9x minus 6. Plus, replace this with its value. It's 140 degrees. What's next? We're going to simplify the expression inside the parentheses by combining like terms. -6 plus 140 is equal to 134. We now have measure of angle M equals 1/2 of the quantity 9x plus 134. Let's call this equation 1. Okay. Next, we're going to use the theorem relating the opposite angles of a cyclic quadrilateral. This quadrilateral LKQM is a cyclic quadrilateral because all the four vertices are on the circumference of the circle. What is the relationship between the measures of opposite angles of a cyclic quadrilateral? It's actually a theorem. And the theorem says that the sum of the measures of the opposite angles of a cyclic quadrilateral is equal to 180 degrees. Angle M and angle K are opposite angles of the cyclic quadrilateral LKQM. Using the theorem, their sum is equal to 180 degrees. Again, the sum of the opposite angles of a cyclic quadrilateral is equal to 180 degrees. Angle M and angle K are opposite angles of the cyclic quadrilateral LKQM. So we can use the theorem. We can say that measure of angle M plus measure of angle K is equal to 180 degrees. This is our working equation. Measure of angle M is represented by this expression using the equation 1. So we can replace this with 1/2 of the quantity 9x plus 134. The measure of angle K is represented by this expression. It is represented by 3x plus 23. So we will replace this with 3x plus 23. The sum of the opposite angles is equal to 180 degrees. This is our working equation in solving for x. Okay, so how do we solve for x? First, let's clear the fraction. Multiply the whole equation by 2 to eliminate the denominator 2. First term times 2. This will be cancelled out. We are left with 9x plus 134. Plus second term times 2. Let's write them side by side. Equals right side times 2, 360. Next step. We are now solving an equation that involves parentheses. So let's clear the parentheses using the distributive property of multiplication. Distribute 2 into each of the term inside the parentheses to eliminate the grouping symbol. Copy 9x plus 134. 2 times 3x is 6x. 2 times 23 is 46. This is equal to 360. Next step, combine similar terms. Let's combine the variable terms. 9x plus 6x is equal to 15x. Let's also combine the constant terms. 134 plus 46 is equal to 180. Equal to 360. Next step, transpose 180 to the other side of equation. We're left with 15x on the left side. Write the original 360 on the right side. When you transpose, don't forget to change the sign of the term. It becomes negative 180 on the right side. Simplify the right side. 360 minus 180 is equal to 180. Isolate x. Divide both sides by 15. Cancel out 15. X is isolated. Find the quotient. 180 divided by 15 is equal to 12. This is the value of x. Okay? We're going to validate our answer in 2 ways. But first, let's plug x equals 12 into the expressions. For this expression, 9x minus 6, let's replace x with 12. 9 times 12 is equal to 108. 108 minus 6 is equal to 102. We now know the actual measure of arc LK, and that is equal to 102 degrees. We can now solve for the actual measure of angle K. Replace x with 12. 3 times 12, 36. 36 plus 23, 59. So the actual value of angle K is 59 degrees. We can also solve for the actual measure of angle M using equation 1. It is represented by 1/2 times the quantity 9x plus 134. Let's replace x with 12. 9 times 12, 108. 108 plus 134 is equal to 242. 1/2 of 242 is 121 degrees. Let's review the theorem relating the measure of an inscribed angle and the measure of its intercepted arc. The theorem says that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Angle M is an inscribed angle. It measures 121 degrees. The intercepted arc of angle M is arc LKQ. And we can now solve for the value of arc LKQ by adding up 102 degrees and 140 degrees. Their sum is 102 plus 140, that is equal to 242 degrees. What is 1/2 of 242 degrees? 121 degrees. And 1/2 of measure of arc LKQ is the measure of the inscribed angle M. So we validated x equals 12 using the first theorem. We can also validate x equals 12 using the theorem relating the opposite angles of a cyclic quadrilateral. And that theorem says that the opposite angles of a cyclic quadrilateral add up to 180 degrees. Let's double check. Angle M and angle K are opposite angles of the cyclic quadrilateral LKQM. The measure of angle M is 121 degrees. The measure of angle K is 59 degrees. If you add them up, 121 plus 59 is equal to 180 degrees. Therefore, x equals 12 is validated using the theorem on opposite angles of a cyclic quadrilateral. Okay? So that's all. I hope that you have understood the theorem relating the measure of an inscribed angle and the measure of its intercepted arc, and also the theorem relating the opposite angles of a cyclic quadrilateral. If you have any questions or you want further clarification, feel free to post your comment. Please don't forget to subscribe to my YouTube channel. Again, I am Tutor Marife MCP. Thank you for watching.